Hi, I'm Keon, and this is part two of my first video, which I showed that I want to show you two methods that some all natural numbers diverges and kind of goes to infinity, diverges. And the first method I showed you by partial sums, and in this video, I'm going to show you about P series, but I'm going to first have an introduction. What P series are? So P series are in this form: the sum of n equals 1 to infinity of 1 over n to the p, where p is the power. And there's a condition for convergence where p should be greater than 1. So the series um, from 1 to infinity of 1 over n to the p converge. And based on what I know, I don't think there's a specific domain for the value of p so that we can actually insert into the function. So there's no like single domain that it should be positive or negative. And in this case, so what I'm gonna do is that so we have the sum of natural numbers. So I'm just gonna write sum of n. So this would be the same as if I write it as a negative power. This would be the same as the sum from n equals 1 to infinity of 1 over n to the power of negative 1. And this is valid because in our domain for n, we have 1 to infinity. So there's no 0. If there was 0, then there would be a problem. This would be discontinuous because there would be 1 over 0, which is uh, non-existent. It doesn't exist. There's no problem with actually writing it as a negative power. And if we know some algebra, n to the negative 1 is 1 over n, and 1 over n is just n. So this is valid. And by p-value, so we know that in this case, p is negative 1. But in this case, you know that p is negative 1, so it's definitely not greater than 1, it's less than 1. So by definition of P series, the sum from n equals 1 to infinity of n diverges. And diverges to what? Diverges to infinity. And this is a similar series to the harmonic series, which would have the sum from 1 to infinity of 1 over n. In this case, the p-value would be 1 because 1 is equal to 1, so it doesn't match the criteria for being greater than 1. So that also diverges. But to find that kind of diverge to what value, or is it go to infinity, or just diverges, there's no like any is a non-existent series. We can also, for the harmonic series, just as we used in the previous part for the sum of all natural numbers, we can use the partial sum. There's not actually a nice formula for the harmonic series partial sum, but we know that there's some like researches that it's like kind of it goes to ln of n plus some lambda, which lambda it's not known, it's like a rational or irrational number, but whatever it is, lambda is a constant, you know. So when we take the limit of ln of n plus lambda, the lambda doesn't matter, and ln of n goes to infinity, as n goes to infinity. So again, we know the harmonic series diverges to infinity, just as this series of all natural numbers diverges to infinity. Thanks for watching.